Come over here, dude.
You can work with a partner.
8, 8,
You guys are making it, so I'm not going to have you work with the partner because we got to. The whole reason work with the partner is get it done quicker because we're not going to take very long on this, and then I'm going to collect it. So week 2, problem number 2. Week 3, problem number 1. Week 4, problems 2, 6, and 7. Some of them are just multiple choice questions. Some of them are like short answer questions. All right? Does that make sense to everybody? Right there in the front of your book. All right, if I don't have your quiz up here, put it up here for me.
I'm just going to take a guess.
A teacher.
Shouldn't have to take a guess on that bonus. That was easy.
Not the bonus.
I didn't even do what I wrote down in my book.
I'd always go by whatever's written in my book. Those are the intelligent people.
No, in the back of it had the answers.
Oh,
I was just kidding, guys.
They're not back there.
Yeah, they are.
No, they're not.
All right. He's looking anyways. No,
I'm glad you're going to believe Dalton rather than me. All right, help me out. Since Dustin's got my book, somebody read me week 2, problem number 2. Quickly.
What is the distance between points A and C?
So they want the distance between A and C. I'm not going to draw the whole number line. I don't know. I can't get it. They switched my thing, and now it's all messed up, and it's just going to have to stay that way.
Kind of cool looking. It looks like
To
Mario.
figure it out. What were the coordinates for A? Quickly. Negative 2.5. What were the coordinates for C?
2. Positive 2.
Positive 2. So if you go from 2.5, negative 2.5 to 2, how many spaces did you move?
4.
4? 4.5? Was that one of the answers?
I think it was. Yeah. D.
What was it? D? 4.5. Week 3, number 1, read that one to me. Is that the 2-part one?
Should week 3?
Week 3, number 1.
Each figure shown at the.
Pardon me, teacher city direction. Mr. Fisher, call the office, please. Mr. Fisher, call the office.
Each figure shown at the right represents a pentagonal number. Explain how you would determine the fifth pentagonal number, and then make a drawing with stage 5 and identify the number you drew.
All I really cared about, and you could explain it if you wanted, but all I really cared about was the drawing and then the number. So this was what, stage 1, and what did it say its number was? 5?
Stage 2.
That's,
Stage
oh,
1 was just a dot.
stage 1 was just a dot, so this was stage 2 and it was 5? Is that right?
Yeah.
Stage 1 was 1 with 1 dot? So you're just counting the dots each time, right? Stage 3, what was the number on stage 3?
12.
12? And it was something like, my picture's not going to be real good, but I don't care.
It's beautiful. Better than mine.
That might be if I would have drawn it correctly. There's not supposed to be a dot there. So then it went out like 1 extra dot, right? And then put another dot in here. Okay, that's terrible. Something like that. So by the time we get to stage 5, that's what we wanted to find, right? What was the other number? Let's do that. 5. What was stage 4? 22. Anybody find a pattern there so you could just at least do the number? Went from 1 to 5 to 12 to 22. Anybody see a pattern? Would this one go up by? So That one went up by 4, what did the next one go up by? 7, because I think Shane's got the right idea over here. Next one went up by 10.
Oh, I got that one.
And that one would be 13.
Next one's going up by 13, so half our answer would be 35. Right, that'd be the number of the 5th stage. Then to draw it, look at it. Second stage, how many dots are there on each side? 2. Third stage, there's 3. Fourth stage, there was 4. So the 5th stage, how many should there be?
Oh, I did draw it right. I just like, oh, that's too many. Darn it. I started it right, and then erased it.
I only did it by the
You scribble up there. You're getting somewhere.
So the 5th stage
Bit crooked, but you're good.
should have all those other little ones inside of it. I'm not gonna draw every one of them because it takes too long. But 5th stage should look something like that.
Did we have to draw the little ones inside?
I probably won't throw a big fit. Should have looked something like that, right? 35 was the number. That was the picture. If you had to explain it, if this was an actual OGT test, which this question was on an old OGT test, if you had to explain it, how could you say you found that last one?
I figured out the pattern.
You could have said, I figured out the pattern that went up by 4, then 7, so it was adding 3 to the original thing each time. You could have said, I just looked at this picture and figured out that the 4th stage had 4 dots on each side, the 5th stage has 5 dots on each side, 6th stage has 6 dots, so on, so on, so on. Week 4, number 2, somebody read that one to me.
According to the Venn diagram, how many students in the sophomore class at a high school have a dog, a cat, or both?
What's the key word there?
Both.
Or.
Or. So do they have to have a dog and a cat, both? No. If it says or, just has to be one or the other. If it said a dog and a cat, then it's only those people who have both, okay? So what do we do to find that?
Add all of them up.
So what were the numbers we had to add up?
126, 33, and 85.
That's 14, 6, 14 again. 244, is that one of the answers?
Yeah.
Which one?
A.
A? Number 6, somebody read number 6 to me. No, we are going to do a whole bunch of these in between now and when February or whenever, that some of you actually take the OGT, so.
What is the approximate distance between points R and T?
What are you going to do to find the distance between those 2 points? Distance formula, and to do that, you got to find the coordinates. Somebody help me out. What's the first point? Don't think it's like some. Look at the book.
Negative 4 and 2.
Negative 4, 2.
That's right.
I'm going to be right when I give you the detention if you don't get your book back out. Get it out. Boom.
Start stomping your feet.
All right, let me get the detention. Okay.
No way. He's gonna learn real quick.
You don't hear Mr. Fisher saying all the time, all you got to do is do what you're asked to do. And this isn't something hard. Having you get out your book isn't something that's hard to do.
Getting it out.
No, you weren't. You were complaining. Next one, you better have it open here in about 10 seconds. Now you're just pushing me.
Yeah, he's pushing you. He's gonna see your limits today.
What's the next one? 3, negative 2. Distance formula, gotta remember the distance formula. Subtract the x's, square it, subtract the y's, square them. -4 minus 3 is our x's. 2 minus a -2 is our y's. What is -4 minus 3? -4 minus 3. -7 squared. 49. Over here we can change it to plus. What's 2 plus 2? 4 squared. 16. 49 plus 16. 65. Now, I didn't have a calculator when I was doing my problem. This is a multiple choice one, right? What's close to 65 as far as the square root goes? 8. Because 8 times 8 is what? 64. Well, is one of the answers there pretty close to 8?
Yeah.
A. 8.1. Number 7. Somebody read me week 2 or week 4, number 7. Is that the blocks one?
Martel's little brother built the tower shown below. Martel counted that there were 100.
Listen. Go ahead, Tristan.
That there were 110 blocks left on the floor. Following the same pattern, how many layers high could the tower have been built?
So he's still got 110 blocks laying there to build with. Instead of me trying to draw the blocks, which that's not going to work out well, the first level, the top level, it was, what was the dimensions?
2 by 1.
2 by 1, right? What was that was the first level. Second level, what was dimensions?
3 by 2.
What is it?
3 by 2.
3 by 2,
No, 4 by 3.
4 by 3. Anybody seeing a pattern there?
Yeah.
What's the fourth level going to be?
5 by
5 by 4. How about the fifth
4.
level?
5.
6 by 5. How about the sixth level?
7 by 6.
7 by 6. Seventh level? 8 by 7. Eighth level? 9 by 8. Good. Do we need to go any farther than that? Who knows? Probably went out far enough. Let's start seeing. We got these up here. Do we even have to recount all these? Those are the levels that he's already got built, right? So is that going to take out of the 110? No, those are already built. He's building other levels, adding on to that. How many blocks going to be in this fourth level? 20? How many blocks in the fifth level? 30. How about the sixth level?
42.
Seventh level?
It's 6, dude. It's a beast. Darn it. Oh my god, it's 56.
56. Eighth level? Is he going to be able to build all those levels? How are we going to find out? Where do I want to start adding that?
20.
So 20 plus 30 is 50. Is that, can he make more levels?
Yeah.
Yeah, probably.
92.
92. Can he make another level after that? So how many extra levels is he going to be able to build? 3. What'd they ask you? Did they say how many more levels or how many total
How
levels?
many layers high is the tower?
So what's the total height? 6. Is that one of the answers?
Yep.
Which one? The last one, the bonus. Looks something like this. What kind of angles do you have in this picture? Vertical and linear pairs, supplementary angles. What was this, number 1?
3.
That's 3 here.
Oh. Yeah, I thought you were asking for
1,
What's here?
2,
2.
3, 4.
They told us what about angle 1?
3.
If angle 1's 30 degrees,
So it's 3.
so's 3, right? Because vertical angles have to be congruent. They didn't ask us either one of those two. They said, what's 2 and 4 got to add up to be?
150.
This is 150. Is our answer 150?
No.
Each one of them's 150, so what's the total answer? 300. It wanted you to add those two together, right?
I'm never trusting this book right ever again. It said 60 on up there.
Wrote that down wrong too. I got it right.
Is that a problem you should get wrong?
No.
Come on now, that's a pretty easy problem.
I just didn't read it right. Put down what number or measure two.
All right, open up your books to page 92, the homework.
There's a dream in your heart, and this heart is your breath. I believe there is divine imagination, giving wings for a created aviation.
On page 92.
Yeah, dream.
You wasn't digging the music?
I can't talk over it. I'm going to run through quite a few of these, so follow along, listen carefully. Help me out if I get tired of holding my book. First one, they give us 4 points. They want to know, probably not best to use red on this one. They want to know how many segments does it take to connect all those to each other? How can I figure that out? Draw them. So if I connect this one to that one, that one, how many so far? And you probably figured out, it's probably not too bad with 4, but if you start doing this for 6, 7, 8, if you don't write down how many you did that first time, are you going to lose track of your count? Probably so. Connect this one to there, this one to there, 2 more. Is that all of them? Is that all? One more, right? That one. So how many total on this one?
6.
13. What anybody get on 13? Because I don't feel like drawing it. 10? I think we did that one in the notes or something, didn't we? Maybe. Problem 16. Determine whether the following statements. You probably can't see that green, can you? 3 points determine a plane. Always, sometimes, or never? Sometimes. How come sometimes? What word did they forget in there? If I just draw 3 points here,
Not on the same.
exactly, very good. 3 points that are not on the same line. When they say they determine a plane, it means there's only one plane. But if I draw 3 that are, what's those called? Give me a geometry word. Collinear. If I draw 3 that are collinear, is there some plane that could come through the whiteboard like this that's going to contain all 3 of those? Yeah. All right. So 3 points determine a plane is sometimes. 3 non-collinear points to determine a plane. That's what the postulate said. That's always. 17. Somebody read 17 to me so I don't have to grab my book again.
Points G and H are in plane, in plane X. Any points collinear with G and H is in plane.
So point G is here. H is here. This is plane X. Any point that's falling on the line that contains G and H, are they going to be in plane X?
Well, sometimes.
Draw 2 points on your paper right now, real quick. Draw 2 points on your paper. Anywhere. Now draw the line that connects those 2 points. Was that line on your paper completely? Yeah. Well, except for when it extends on out, it's gonna be off the paper because the paper ends, right? We're not gonna talk about that though. So if 2 points are on a plane, is the line that contains those 2 points gonna be on that same plane? Yeah, always. Somebody read 18 to me, what's it say?
The intersection of 2 planes can be a point.
The intersection of what?
2 planes can be a point.
The intersection of 2 planes can be a point. So you got 2 planes, can they ever intersect at a point?
No, it does.
It's always a what?
Line.
A line. Now, if you had 3 planes, could they intersect at a point?
I didn't know they could, but sure.
Yeah, because think about it. I got the ceiling, that wall, and this wall. They all come together where they intersect at a point. So 3 planes could come together at a point, or intersect exactly 1 point. 2 planes either are never going to intersect, or they're going to intersect at a line. What's 19 say?
Points S and T, and U determine 3 lines.
Points S. Did they show a picture of them?
No?
So S, T, and U make up 3 different lines. Always, sometimes, or never? Sometimes. I drew them this way. The way I drew them, they make up how many lines? 1. But could I have drawn them this way? Now how many lines are they going to make up? There's 1. That's another one. That's 2. That's another one. So how many did they make up there? 3. So this would be sometimes. Problem 22. Somebody read problem 22 to me. This one's got the picture, doesn't it? So looking at that picture, we got, name the blue plane for me.
K,
K. Name the yellow plane for me.
J.
J or F or whatever that is. I can't even see it.
I think it's a J.
It's a J. We'll go with J. That makes sense if they did K. What 22 say?
They're collinear.
2 points?
C and D are collinear.
Do I even have to look at the picture? If I got C and D, look, I'm holding C and D behind my back. Are they collinear to each other?
Yeah.
Yeah, any 2 points are collinear. So what were they asking us? Oh, state the postulate. So we flip back over to the other page. What postulate? And this one you probably know. What postulate tells me that they're collinear? Don't give me a number. Just tell me what it says. 2 points, what?
2 points line up planes and the entire line, any 2 points line.
That's one before that. Or one. 2 points make a line. That's all we needed. 23, what's 23 say? C and D, no matter where points C and D are they ever always gonna make a line? Yeah. Next one. 23.
We just did 23.
That was 22. Line XB lies in plane K. So line XB. Is X in plane K? Point X, is that in plane K? Is B in plane K?
No. Yes and no.
It can't be yes and no, it's either gotta be yes or,
It's on the line.
well, that's all right. Is it still in plane K?
Yes.
Yeah, it's actually in both planes, isn't it? Well, if both those points are in that plane, what did we just show on your paper there when we drew that line, when you drew the 2 points? If both points are on the plane, then the whole line is going to be on the plane. Now that's the one that you were reading a second ago, Tristan. Tell me what it was said again.
If 2 points lie in a plane, then the entire line containing those points lies in that plane.
So if 2 points are in a plane, Then I'm being lazy here, line is in the plane. 2 points are in the plane, then the line's in the plane. Does that make sense to everybody?
Yes, sir.
If you got 2 points and you draw them somewhere on your desk, is the entire line that's containing those 2 points going to be in there? Yeah. 24, what's 24 say?
Points A and C and X are plain.
Points A, C, and X are coplanar. Again, this sort of goes back to this one. Any 2 points in the world make a line. Any 3 points in the world make a what? Plane. So do I even have to look at the picture to decide this? No, they gave me 3 points. I know that there's some plane, even though it might not be shown on the page there, there's some plane that contains all 3 of those. So 3 points, and I'm messing up here because what word should I put in there?
Mr. Eversole?
Yes,
Do you have Jesse Schaefer?
yes,
He's in the high office, please.
sure.
Thanks.
What should I put in there? 3, we talked about this a minute ago. 3 non-collinear points, right? 3 points that aren't on the same line. So 3 points make a what? A plane. 3 points make a plane. It's 25 say. 2 points make a line, 3 points make a plane. Can none of you read this morning?
AG lies in plain.
J or whatever.
I don't know what that is.
So A and D. Point A in plane J. Point A in the yellow plane. Point D in the yellow plane. So is there a line in the yellow plane?
Yes.
Yeah. That goes back up to here, right? So if 2 points are in a plane, then the line is in the plane. Don't go. Make sure you know exactly what it says. Don't go by my caveman writing that I'm doing here. Leaving out a bunch of words and everything. 26. X and Y are collinear. Is that true? Points X and point X and point Y collinear? What do you know about any 2 points? They're always collinear. So 2 points always make a what? Make a line. 2 points always make a line. It's 27 say. Is that a different part?
Points Y, D, and C are coplanar.
So now you got 3 points. Are they coplanar?
Negative.
3. What do you know about any 3 points in the world? They're coplanar. So yeah, 3 points.
Oh, I was thinking collinear.
3 points make a what? Plane. 2 points always make a line. 3 points always make a plane. Now, do those 3 points have to make up exactly one plane? No, if they were collinear, then they could make up a whole bunch of different planes. 28. What's 28 say?
Point C is the midpoint of
Oh, this is the proof, isn't it? Go ahead.
segment AB, and B is the midpoint of segment CD. Prove that segment AC is, I forget what that one is.
Congruent.
Congruent. to segment BD.
So it said C is the midpoint of AB. So what's that tell us about these 2 segments? They're equal to each other, so I'm going to mark them. Then it says what else?
B is the midpoint for CD.
So it goes out this way. D's out here somewhere. And what do we, if B's the midpoint, what do we know about these 2 segments? They're congruent. How do I mark this segment BD out here then? If I put one tick mark on this
You have
one,
to put two.
2,
Three.
3,
One.
why 1?
Because they're congruent.
Because what did it tell us about this one? We know that these two are the same. Well, if that one's marked with 1, then this one should be marked with 1. Now, we want to write a paragraph proof about this. How are you going to start off a paragraph proof? I'm going to make you write about 10 of them if I don't get some good answers here in a minute. So for tonight's homework, be ready to write about 10 paragraphs. Help me out. What do we start with?
Segment AB.
All right, so something like maybe, let's make it, we know, now this is a good way to write anything in English class, right? Shouldn't start out with I or we or anything else. We know what?
We know that segment AB.
C is the midpoint for segment AB.
We know C is the midpoint of what segment? AB, good. And what other thing did they know, or did we know?
That B is the midpoint of CD.
B is the midpoint of segment CD.
Like this makes this splits it into 2.
So now let's, so C, you got the right idea. We need to say something, and then we're going to use that as our reason for it. What did we say once we knew C was the midpoint?
But sides.
Yeah, where it's congruent.
So what's congruent? Segment AC is congruent to segment CB. And what was the next part? What'd you tell me about B was the midpoint, so what's that tell us about these two? So segment CB is congruent to segment BD. Now we can't just write that. Now is where we got to use what Lucas was trying to say a second ago that I cut him off on. You say, okay, I know these two are congruent, I know these two are congruent. You can't just say you know that they're congruent. You got to give a reason. And what's the reason? Because what? What were we talking about up here? Midpoint. What's a midpoint do?
Split the segment into equal.
Exactly what Lucas just said. Because a midpoint splits a segment into two congruent segments. Hopefully you know that, guaranteed, hint, hint. I think I mentioned the vocab test coming up here real soon. Guess what one of the terms on there is? Midpoint. Midpoint's point that splits a segment into two congruent segments. Now, are we finished? Did we prove what they wanted us to prove? What did they want us to prove? AC is congruent to BD. We got that in here somewhere? We do? No. So that's what we need to go to next. And I'm going to say something like, try to use a big word here, make myself seem smart. Therefore, I know, oops, I'm not going to make myself seem smart if I can't spell no. Therefore, I know, looking at this, how can you tell me that what segment AC is congruent to segment BD? Does everybody see that?
Yeah.
All right. They have, what law did we just get done covering a few days ago? It said syllogism. All right, so we could use that. I'm actually going to use something that we're going to talk about today. If segment AC is congruent to CB, segment CB is congruent to BD, Therefore, I know that segment AC is congruent to segment BD, and this is something you had in algebra, because of the, anybody remember what property that was? A equaled B, B equaled C. Close. Close. It's a good guess. Because of the, I can't spell, transitive property. Transitive property said A equals B. You remember it after a day because we're getting ready to write it. B equals C, then what can you conclude from that? A has to equal C. So that's our paragraph proof. Opening statement, we stated what they told us, the given information, right? We could have probably said, we probably should have put a thesis statement in there. Maybe we are trying to prove what? Segment AC is congruent to segment BD. And I wrote it backwards. So we know, so we gave our given information. That's why I'm not an English teacher, because I forget all that stuff. We know that these things are true. Then we said, since we had midpoints, these two segments had to be congruent. These two had to be congruent because a midpoint splits a segment into two congruent segments. Then from that, we can say these other two segments are congruent by law of syllogism we could have used, or the transitive property. What 34 say?
For all the values of x, ax to the power of 3.
Hold on. So this is in parentheses, right?
Yeah.
8x to the fourth.
Yeah. Minus 2x,
2x squared.
Yeah, plus 3x minus 5. Parentheses minus another parentheses. 2x power of 4 plus 3x cubed. Not 3x, it's x.
Just x.
I did this in my paper too.
X cubed.
Yeah. Plus 3x plus 5 equals.
They want you to simplify that. First thing, when you're subtracting off this second parenthesis, what's that do to every term in that parenthesis? In this case, it does the opposite of it, right? So I could drop all. Do I even need the parentheses on this first part? No, they're sort of a waste. So I'm just going to rewrite it like this. Stupid big cursor makes it hard to write. I can't see. Anytime you have a minus here, it's like you're distributing out a -1 to everything inside that parentheses. Well, if you're distributing out a -1, then that just does what? Maybe. Changes the sign. In this case, it's going to make them all negative because they all started out as what? Positives. Now, is that simplified? Is that all we can do to that? No, you collect like terms, right? 8x to the fourth. Has that got any like terms? What's 8x to the fourth minus 2x to the fourth? 6x to the fourth, good. So those are gone. Let's get rid of them. Pen will work. Where do you go to next?
3x. Well, no, actually, go to 2x squared.
You want to keep it in order, right? Remember in algebra you had to keep it in descending order? That's what we want to do here. Any other x thirds in here? So we just write that one down. We can get rid of it. Now where do we go? We want the second powers, right? Any like terms for it? So minus 2x squared takes care of that one. Now where? We got a 3x and a negative 3x. What's that give us?
X.
Well,
Does it give you x? No, they cancel out completely.
that's not the problem, because then 5.
What's a minus 5 and a minus 5?
Negative 10.
Will that simplify any farther? Is that one of the answers on there? What was it? A? So be able to simplify all any kind of algebraic sentence, any kind of algebraic expressions, be able to simplify them down. Stuff you should have learned in algebra last year, not real difficult.
That's really probably getting into this.
All right, what I want you to do, get out a clean sheet of paper. On that clean sheet of paper, we're going to do this very, very quickly. You're going to write 4, 5, 6 sentences about this video.
Do I have to?
Yes, you have to do it.
Are we turning it in?
Yes, you're going to turn it in, so make sure your name's on it. I'm going to show you this video. Watch closely, because you're only going to take about 3 or 4 minutes to do this. Shouldn't take any longer than that to write 4 or 5 sentences.
What's it about?
I guess you'll find out here in a minute, won't you? All right. It says, is it possible to fix the mix-up? That's what you're going to ask. Now, once you start writing,
Don't stop.
what I want you to write about is what information might you need to know, something like that. What kind of math are you going to do to try to solve the problem? What are you just any ideas that you have about this? All right? Shane might write down, I need to know how many elephants are in the room.
What?
All right? So, if that's one of the questions that he needs to know before he can solve the problem, great. So, is it possible to fix it? Tell what information you need, so on, or how you might fix it, whatever it takes. Start writing. Huh? Do I need to move you to the middle?
Add 6 questions about it.
Just write 4 or 5 sentences. Doesn't have to be asking questions. Might be asking questions, might need to know, we need to know this information or anything. How would you solve the problem? Can you fix the problem? What information do you need to know? I don't care. Write something. Huh? Yep.
Does this have to be mathematical at all?
Not really.
Okay.
Make sure you're writing the sentences too. No. Writing my way. When you get finished, you can lay it up here on the blue chair. You realize there's no right answer, right?
Yeah.
About 1 more minute. Thinking longer than 1 more minute, then you put too much thought into this.
It's pretty complicated.
Yeah,
Are you gonna tell
I think
us?
I'm saying the wrong, I think I'm thinking like a lot harder than it should. I'm saying the wrong thing.
Wait, can you?
Can you fix it?
Yeah, maybe you might want to
Find out here.
Like, I put yes and no maybe. Like, what if there's like a chemical you could put in there? Like all this, you never know. Like, I don't know.
That's, so maybe that's it, yeah, maybe you could, if you wrote that, yes, there's a chemical that separates paint.
I guess there might be.
Maybe.
You know.
Yeah, exactly. And if there's not, maybe that's something that you could invent, right?
I don't want to prevent it. It's very difficult.
I thought you could restart.
I gave 2 examples. Either you could level it out with those extra.
All right, if I don't have your stuff,
All right.
finish up last sentence, put it up there. Is it possible to fix this mix-up real quick?
Yes.
Yeah, you could. What would you have to do?
Add 25 words.
How many? 24 reds. If you added 24 reds, that would make a total of 25 red, and then you'd have to add how many whites? None, because that put it 25 to 5, and she wanted the ratio of 5 to 1. Now, what information might you need to know before that? Do you have what?
We had 25 red ones.
Do you have enough reds to put in 20 some of them? All right, make sure you got enough paint. So this one, you know, you could actually answer it, yes, and it actually does have an answer. Some of these, one I'm going to show you next time, it also has an answer, but more along the lines of what questions could you ask? What information do you need to know?
Was there a
Give,
yes?
give me something that you guys said.
Is there a yes or no question? Or you could reach a right or wrong answer to this, or like, okay.
So,
You could wash out.
yeah, you could wash out the paint and restart, as long as you got enough paint, right?
No, that's so, yeah.
Is that a possible way to fix it? Yeah.
We put a chemical in there, like,
That was the weirdest little bit.
I don't know.
What else?
Put a chemical in there.
Put a chemical in there, maybe. If you can find a chemical that separates paints. I don't know if there's any such thing or not, but. What else? What information might you need to know before you decided whether it's possible to fix it or not?
How much paint you have?
How much paint you have?
If you mess up, what to do?
If you actually have something to do what? Some of you said start over. Well, then you got to be able to do what?
Throw the paint out.
Clean the pan out. Well, if it's acrylic paint, can you clean the pan out? Not with just water. It's never going to come clean.
You either gotta have another fan or.
Okay, so that might be a question you have.
What if it's dry though?
If the paint's dry, let's hope it didn't dry up that quick, but
Well,
if it was, then you'd have to start all over anyway, because you wouldn't be able to paint with it, right? All right, go ahead and start copying these notes.
I'm tired of this crap. Like, we got He always disses on the music.
Let's forget this part today, because we're going to hurry.
We always forget that part.
Yeah. Yeah, we've been here lately.
Yeah, I'm not gonna
All right, what we're going to cover today, we should be able to get through this fairly quickly. I'd like to have been able to do a few problems in class together, but this is stuff from last year, just adding a little stuff to it. So use, and today is the what, 5th? 4th? Today's the 4th, so if you wanted to write that down, 11-4 to help you keep your notes in line. Use properties of algebra to write formal proofs. A formal proof is also called a two-column proof. Two-column proof. Guess what you're going to have in a two-column proof? Two columns, and you guys apparently call that what? A T-chart. Use it in other classes. It'll be the same idea in here, and I'm going to show you how to do those. So the algebra stuff, the two-column proof is going to be new to you, but the algebra stuff's not going to be new. All right, go ahead and start copying down these properties. Don't do that. Copy down these properties. I want to real quickly on these three and the one on the next slide, add in something right here. So, addition property of equality. Add that in on all three of them. I apparently was too lazy to put it in there. What do you think the addition property, just the addition property is? It's where you just do what? Add. Addition property of equality is where you add something to both sides of the equal sign. So two different things. Addition property is where you just add. Addition property of equality is you add something to both sides of the equal sign. And that goes for not only addition, but for multiplication, subtraction, division. Anybody remember any of these properties?
Yeah, I remember it.
Might not remember the first one. Don't use that a whole lot in algebra. The rest of them. Symmetric property, you probably don't remember, but you used it a lot in algebra because about half the time when you got an answer like this, that was your final answer on a problem. Did you leave it written that way? No, what'd you do? You turned it around, didn't you? Instead of saying 5 equals x, it's x equals 5. You turned it around, and that's actually the symmetric property. Symmetric property says you can turn the equation around. The reflexive property, you might want to write this in there somewhere. We'll write it down several times throughout the year, and it's going to be very, very important once we get about halfway through the year. Anything equals itself. Reflexive property is like the easiest property there is in the world, but for some reason it seems to give a lot of students trouble. Anything equals itself. Transitive property, we just got done talking about transitive property a couple minutes ago. If A equals B, B equals C, then A has to equal C. What law is that like? It's like the law of syllogism, sort of. Law of syllogism. Addition property. Addition property just says if you add the same thing to both sides of the equal sign, the equation's still the same. Subtraction property of equality says if you subtract the same thing from both sides, still the same. Multiplication property of equality says if you multiply both sides by the same thing, both sides of the equal sign by the same thing, then your equation's still the same. Guess what the next property is on the next slide? division, property of equality. So you could go ahead and write that down if you wanted. Division, property of equality. Anybody tell me what you think the division property, how it would be stated out like this?
A divided by, or,
If A equals B, then
yeah, then A divided by, or
A divided by C equals A divided by C.
Dude. This class is fast.
Tristan, how close are you?
okay, you're good.
It's almost up to Candy Mountain.
Yeah, almost there.
All right, go ahead and write these down.
Getting used to that, man. What's up with that?
I'm trying to turn it back on, but no, it won't come back on.
That's depressing.
Get rid of this last thing.
No last name. If you're already down there, you got some problems. Scribbling on
You have it written.
it? Dude, you're pro if you read that. Pretty good.
On the last thing, all it was is saying if you're just adding, subtracting, multiplying, or dividing, not on both sides of the equal sign, but just on one side, like if you're combining like terms, then you're just using addition or subtraction or multiplication or division. You're not using a property really. Well, it is a property, it's just the addition property, not the addition property of equality. So division property, and again, remember this should say of equality. Spelled it wrong, but it'll be all right. Substitution, what's the word substitute mean?
Fill in.
You fill something in its place, right? So if we know A equals B, then anywhere you see A, what could you put in its place? B. That's substitution. No, not or C in this case.
Not up to C?
No, because they didn't tell us A equals C. Distributive property. Everybody remember distributive property? Hopefully that's one that everybody seems to know pretty well. And then if you're just collecting like terms, then all you're using is addition, subtraction, multiplication, or division. Usually if we're collecting like terms, we're doing that, either addition or subtraction. Right, a two-column proof again is called a formal proof. So if you just write down two-column proof, formal proof, make sure you know that. Paragraph proof is called a what again? Paragraph proof is called an informal. Two columns formal, paragraphs informal. I'm going to show you this problem just real quickly so that you have an example there in your notes.
You should do slides like this more.
With the examples on it.
No, with like the colors in the background.
No.
Looks cool.
But he's focused on like else.
All right, watch carefully. This is a two-column proof. In a two-column proof, you have statements. Make sure you're writing this down. That's your first column. For every statement, for everything that you make a statement about, you got to have a reason. When you're doing these, the book letters theirs, they do like A, B, C, D. Please don't do that. Let's do 1, 2, 3. So if I have statement 1, I'm going to have reason 1. Your statement 1 is going to be your given information normal. This is what we're given this time. So we're just gonna write that in here, 5x plus 3x minus 2 equals 7x plus 8. As we do 2-column proofs throughout the year, most of you are gonna like the given information, because guess what you get to put over here for your reason? It was given. It's that simple. If this was on a test, you'd get 2 points already. Is that too hard to get 2 points?
Nope.
Sort of like free points.
Free.
Now, what's number 2? What's the first thing we're going to do to start to solve this algebraic equation? Collect like terms. What's that give you? So 8x minus 2 equals 7x plus 8. What did we do to go from step 1 to step 2? Collect like terms. And all we did was addition, right? So I'm just going to put addition property. You could also put substitution. Anytime you're just changing something, you're actually using substitution. You're saying, hey, I know 5 plus 3 is 8, so I'm substituting 8 in the place of 5 plus 3. So substitution fits in for addition property. Notice this is addition property, not addition property of equality, because we didn't do something to both sides. What do we do next?
Subtract 5 from each side.
Subtract 2.
Let's get all the x's on one side. So subtract 7x on both sides.
Oh, sorry.
What's that give us? X
I was looking at the given.
minus 2 equals 8. What's our reason there? What allowed us to go from step 2 to step 3? Subtraction. Property. Please make sure, don't just abbreviate subtraction. SUB, because what else could it stand for? Substitution. Subtraction, property of equality. I'd accept that simplified out so you don't have so much to write. Now what do we do?
Minus 2.
Close.
Plus
Add 2.
Oh.
Add 2 to both sides. What do you end up with? X equals 10. What's our reason going to be there? No. And that's a good point. Should it ever be the answer or given or the proved statement or anything like that? No. If you're just going to write that in, you should have a real reason. If you're just going to write given in here, well, if you were given that, then you were sort of stupid to go back and do the whole problem anyway, right? If it was given to you. So this would be addition, property of equality. Are we finished? Yeah, I know they didn't put it, usually they'll have prove. In the book they'll say prove x equal 10. I didn't put that on there because I didn't want you to know what x was. Before you go, this isn't on Moodle, so sit still. Not that. Not that.
There we go.
Not that.
Man, this looks easy.
All right, that's your assignment.
There you go.